Dear students, welcome back. In the previous session, we have discussed about the semiconductors and also transistor. And the transistor mainly works on principle of semiconductor diode, isn't it? Yes. Now, in this session, we are going to discuss about rectifiers. Okay. So, what is the function of rectifier means? So, rectifier is a device which performs the function called rectification. Okay, a rectification is the process of conversion of alternating current into direct current. Okay, the device which produces such process is called as rectifiers. These rectifiers can be metal rectifiers or the diode wall. We know that we have already discussed about the diode wall in the previous session. Now we are going to discuss about metal rectifier in this session. Okay, so this is an copper oxide metal rectifier. Okay, so this metal rectifier works on the principles of semiconductor diode. Okay, already we have discussed this semiconductor diode in the previous session. Okay, so one type of rectifier in this, one type of rectifier consists of copper disc coated on the surface with copper oxide. Okay, so this is a copper oxide metal rectifier. So in this copper oxide rectifiers, so it consists of a copper disc and which is coated with copper oxide, isn't it? Here the copper oxide works as P type of semiconductor. Okay, and copper being a metal which is having free electrons, so it acts as n type, whereas the copper oxide acts as p type. Okay, so when the two materials are in contact, when this copper and copper oxide are in contact, a potential difference develops at its junction. For example, this is the copper disc and which is in contact with the copper oxide. At this junction, what will happen? Potential difference develops at their junction. When the rectifier is connected into a circuit, so the same thing is connected into a circuit with the copper negative, in related to the copper oxide, current passes more easily than when the polarity is reversed. That means here what happens, the current passes more easily from copper to copper oxide. Not only in that way, but it will move in reverse direction very easily than from copper to copper oxide. That means in this type of thing, the electrons will pass from copper to copper oxide, isn't it? Copper CuO. So copper to copper oxide. But the electrons will again move from copper oxide to copper very easily. Okay, so it should not be done. Why? Because the rectifier only helps in unidirectional flow of current, isn't it? So the reverse direction should not take place. So for this reason, they have given more EMF to the copper oxide. Okay, so then what will happen? Normally each metal rectifier will rectifies only 8 volts. Okay, So that means after 8 volts, if the current is rectified, there may be a chance of returning back. So for that reason, they have given some extra volts to this copper oxide layer. That means it has to maintain the 10 volts. Okay, so then what happened? There is no reverse flow will takes place, and the EMF is continuously. The EMF is maintained continuously until the desirable volts what we required. That means each metal rectifier rectifies 8 volts. For example, if we require 100 volts, then we need 10 discs. Okay, we need 10 discs. Then only we will get that much of current in one direction. Okay, so these are the common principle of working of the metal rectifier taking place. Now we will see the construction of this metal rectifier. Yes, so the rectifier, the copper rectifier, consists of an appropriate number of copper discs. So in each one is in one metal rectifier, and it is connected here. So if you take in a single thing how this internal structure is designed, means here A is the copper disc. Okay, this copper disc which have been oxidized on one surface, normally this side. Okay, copper oxide layer. Okay, and the other surface is mounted on an insulated rod. So the other surface is mounted on the insulated rod, that is E. E is the insulated rod. Okay, and if you see the B is a thin layer which is in contact with the copper oxide layer, that is graphite. B is called graphite. This dark layer is called as graphite. And after that it is having a lead disc. C is called as lead discs. And after this lead disc you'll have an fin is present. So this D is called fin, which is made up of with aluminium. It is called as aluminium cooling fin. Okay, and which separates, this aluminium cooling fin separates with the next unit. So this is the structure. Okay, the materials are chosen so that a potential difference develops only at one surface of the copper oxide, and lead is used because, it being a soft metal, it makes good contact with the other discs when they are bolted together. The cooling fin serves to radiate the heat generated, which would otherwise interfere with the working, and are also used to lead the current in and out of the rectifier. Okay, so the symbol and construction of the rectifiers, if you can see, this is the symbol and this is the construction of the rectifier. In the symbol, the arrowhead represent the copper that shows the direction of the electron flow. So this is about the metal rectifier. And selenium rectifiers are also used. Selenium is a p-type semiconductor, and a tin alloy is in contact with it, acts as an n-type. The rectifying units are separated by appropriate materials and each one will rectify up to 18 volts. But in the case of copper rectifiers, that is in this copper rectifiers, it can rectify only up to 8 volts, whereas in the selenium rectifiers it can rectify up to 18 volts. Okay, so this is about the metal rectifier. Okay. Okay, the main use of this metal rectifier is the rectification of alternate currents to the direct currents. Okay, so in the next session we are going to discuss about the rectification, how there are different kinds of rectification out there. So with the help of diode walls and this metal rectifiers, we can rectify the uh, alternate current to direct currents. That will we can see in the next session. Thank you.